let's get ready for Chapter 2 of Geometry. This is going to be a very short one. Chapter 2 is really unique. It has a lot to do with logic and reason. So, not a ton of math, a little bit of math, but more, proving things and more being able to go from point A to point B and filling all this stuff in between. So, it's a very unique chapter. So, we need to be able to explain ourselves very well. So we're going to focus on what's called error analysis, where we look at a problem, in this case, find out why it's wrong and explain why it's wrong and what we need to do to fix it. So problem one here, find the line that contains the error, explain the error, and solve the problem correctly. So let me see what we have. We have x minus, okay, so you have -5 attached to a parenthesis, so you should distribute -5 to x, which will give you -5x, and then -5 to 1, which would give you -5. So line 1 is the issue. So we're going to end up doing this entire problem. And we're going to explain our steps verbally. I'm not going to write it down. I don't have the space to write it down, but I'm going to explain very carefully what I'm doing. They went wrong by not distributing the -5 to the 1. It should be x, and then -5 times x is -5x. That wasn't the problem. The problem was -5 times 1 should have been -5. That will equal 3x plus 2. Is my face going to be in the way? No, I think I'm good. So let me see. So that's what they should have written out. What I have to now do is combine like terms. So x minus 5x is going to be -4x minus 5 equals 3x plus 2. I have an x on the left and I have an x on the right. So the best thing to do is get rid of the smallest one. So I'm going to add 4x to everything. Add 4x to everything and cross you out. -5 drops down on the left. That's going to equal 7x plus 2. Now I have to subtract 2. That leaves me with -7 equals 7x. And divide both sides by 7. And x is going to equal -1. I'll put that there under my face. Oh, hello. Am I looking in the right way? Hello. Oh, but this problem was wrong because they didn't distribute properly. Being able to fix the problem is sometimes just as important as being able to explain where you went wrong. And a lot of this chapter is being able to explain. So good for me for being able to do math. That is kind of my job. But am I able to explain the error? That's the key. And I think I did. Is the solution correct? Explain. All right, so we have a similar problem that we had before. I have 5 times 1, which is 5. I have 5 times 4h, which is 20h, plus 2h, that's still good, equals 27. That's still good. They went from 5 plus 20h plus 2h to 27h. That's where they went wrong. So no, it's not. And the reason why is because they combined all the terms on the left here when they only should have combined these two terms. So it should be 5 plus 22h equals 27. And I think actually in the end it's just going to work out anyway, so... Although I'm not a fan, it's going to work out anyway. Look at all those 22s. Taylor Swift would blow her gasket if she knew that I had 22 all over the place. I don't know about you, but I'm feeling there's a lot of 22s all over. So was the solution correct? Yeah, I guess it was. It was just done wrong. God is good. It worked out. Doesn't always happen that way. Doesn't always happen that way. That's called error analysis. Now what I want to do is explain myself to see if I'm right or wrong. This is more me proving whether or not this is a triangle. The way you see if a triangle is a right triangle or not a right triangle is you use the Pythagorean theorem. This idea is called the converse of the Pythagorean theorem. You see, rather than me finding a missing side, I have all of my sides and I need to see if this is right or not. Okay, so looking at this picture, not even looking at the picture, looking at these numbers, I have to let 13 be C because it's my largest. So if this is a right triangle, 13 would have to be my hypotenuse. I can call you A, I can call you B. It doesn't matter as long as the longest side is C. So I'm going to find out and see if 11 squared plus 5 squared equals 13 squared. That's my job. 11 squared is 121. 5 squared is 25. 13 squared is 169. 121 plus 25 is 146. And the last time I checked, 146 does not equal 169. So is this a right triangle? No, it is not. It is not a right triangle. And the reason why it's not a right triangle, if I were to explain myself, and I'm not going to write it out because of, handwriting and blah, 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 but it's not a right triangle because it doesn't follow the Pythagorean theorem. The numbers will not work for the Pythagorean theorem, and Pythagorean theorem only works for right triangles. So when I tried to substitute my equation or my numbers into the equation, the Pythagorean theorem, it did not work. So therefore, it's not a right triangle. The converse of the Pythagorean theorem failed. Failed. One more. Use the distance formula to show that the length of a line is less than 8. So the distance formula is a big square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. I have 2 points. Doesn't matter which one's which. I'm going to call you x sub 1, y sub 1. And I'm going to call you x sub 2, y sub 2. The distance is going to equal x sub 2, which I labeled 1, minus x sub 1, which I labeled 7, squared, plus y sub 2, which I labeled 3, minus y sub 1, which I labeled 6, squared. D equals the big square root of 1 minus 7, which is negative 6, squared, plus 3 minus 6, which is negative 3 squared, negative 6 squared in parentheses is 36, 3 squared in parentheses is 9, D equals the square root of 45. Now here's the thing. I don't know what the square root of 45 is. No clue. Not a stinking clue. But what I do know is that the square root of 64 is 8. So what I'll say is this, and this is kind of going out of my way, but the theme of chapter 2 is explaining yourself in a way that a math teacher would understand. And guess what I am? Since I care about 8, since the square root of 64 is 8, and the square root of 45 is less than the square root of 64, then the line is less than, I'm running out of room, so the line is less than 8. So again, I'm just using the numbers that I have in front of me. I don't know what the square root of 45 is. I do know that the square root of 36 is 6. The square root of 49 is 7, so this is going to be 6 point something. I just don't know the exact answer, so I'm just going to use it. I'm going to explain it that way, and that's a way that does make sense. I don't know what the square root of 45 is, but I do know that the square root of 64 is 8, and I need to prove that this is less than 8. So since 45 is less than 64, then the square root of 45 is less than the square root of 64, which means this line is less than 8. Get it? Got it? Good. And on that note, bye.